Okay, we are going to work on some module 2 work. And it is a kind of a double unit. We're going to go and look at some of the parallel line and a bit of the triangle work. Some of the actual, I don't know, meat and potatoes number type questions. Okay. Couple of things we need to know that hopefully you've brought with you, but if you don't, I will start with. One property is property of any triangles. That the angles in a triangle, oops, sorry about that, add to 180 degrees. Let me clean that up a little bit. Okay, so that's one thing to bring with you. Another thing, if you have an angle on a straight line that's cut like this, so you have, say, angle A here and angle B here, a straight angle is 180 degrees as well. Okay, so a straight line or a straight angle is 180 degrees. So that little piece of information we'll put in our back pocket when we go to do these questions as well. Now, let's get into parallel line theorem. We'll talk about the different things that come up, and then we'll see if we can end off with some examples. I hope to not keep you too long. All right. So a few things about parallel lines. If you're drawing them or you see them somewhere, the way that we indicate they're parallel is with the arrows. Okay, so the arrows indicate that they're parallel. And then if they're cut in half by a line, we call this line a transversal. Okay, so that's what our questions kind of start out looking like. Now, as soon as we take a set of parallel lines and cut them with a transversal, we get 8 different angles. So I'm just going to number them 1, 2, 3, 4, 5, 6, 7, 8. It really doesn't matter how I number them, but we've got 8 angles. And it gives rise to a whole bunch of different properties that we need to know. So that's what we're going to run over, first of all. And then I've got 2 pre-prepared questions that we'll throw up, and we'll look at how we apply all of these different theorems. Okay, so the first type of angle that comes up that we can talk about is opposite angles. Now, I always want to call them vertically opposite. So if you're watching a YouTube video or something, just know that opposite angles and vertically opposite angles are the same thing. Okay, us older folks, we always call them vertically opposite. The definition of opposite angles are angles directly across a vertex. Ooh, do you guys know what vertex is? From each other. I'll explain what that is. So in orange, in a dot, there's our vertex right there that I'm doing kind of larger. So kind of across the way. So 2 angles that are opposite, angle 1 and angle 3 are opposite angles. And I'm going to get a little bit shorthand and just go OPP for opposite angles. They are equal to each other, okay, and are equal. So angle 1 equals angle 3. Another set of opposite angles, angle 2 equals angle 4. So if we want to do a little bit of highlighting, this guy equals that guy, and I can change that guy equals that guy. And similarly down below. Angle 5 and angle 7. So angle 5 equals angle 7 because they're opposite angles. And angle 6 equals angle 8. So we get a whole bunch of equality happening here. Okay, so that's opposite angles. That's one of the types of angles that you're required to know. Now, something that we already talked about right up here with the green star that I just put, straight line or straight angles being 180. There's another word we use for that, and the word is supplementary. Supplementary means adds to 180. So let's write that down as our next one. Supplementary. Supplementary. Here we are. Add to 180. So in this case, if they're along a straight line, angle 1 plus angle 2 would equal 180. Now we don't know what angle 1 is and what angle 2 is as a number, but we do know that when we add them, they would add up to 180. And you see there's a whole bunch of sets. Angle 2 plus angle 3 would equal to 180. Why doesn't everyone open their little chat box and type me another set of angles that are also supplementary, so you guys get a little bit of a chance to get involved? Perfect. Yep. Great. That's second right answer. Super. Try to give it a go, everyone. Okay, so there's many opportunities there to have supplementary angles. So that's a good one, kind of a bit of a get out of jail free card. Sometimes it helps you find some angles when you can find them right next to each other. Okay. Angle 6 and angle 8 are actually opposite angles, not supplementary angles. So we just have to be cautious that they have to be touching. Okay, the two angles, if they're supplementary, if you're having a bit of a hard time, the way to think of this is that they're touching, they're right next to each other. Okay, so those are two types of angles. Another type of angle, and I'm going to see if I make my board, oops, is that still okay to see? It's not too small, is it? Because I want to be able to put all of this here. Let me know if I've gotten a little bit too small. So opposite angles, supplementary angles. Let's write over here another type called alternate interior angles. These ones are harder to define. They are the following: angles on opposite sides of the transversal next to different parallel lines. It's a pretty long complement. I'll get rid of some of my highlighting here and just put the numbers back so then it's not distracting for you. So we had 1, 2, 3, 4, like that. Okay. So alternate interior angles. They're angles on opposite sides. Oh, I should also say this. Angles on opposite sides of the transversal next to two different parallel lines inside. So I have to say that as well. Inside the parallel lines. Because that's the word interior. Whew, that's quite a long definition. So in 20-2, we're not so concerned that you know these definitions to parrot them back to me, just that you know which ones are which. So inside, the only ones we have to choose from are 3, 4, 5, and 6. And when they're on the opposite sides, and then next to alternate different parallel lines, the two answers here are angle 3 equals angle 5, because 3 is on the top next to the top line, 5's on the bottom on the other side next to the next line, and angle 4 is equal to angle 6. Same reason. Angle 4 is up top on the left and angle 6 is down on the bottom. Okay, another type, corresponding angles. The definition here is angles in the same location between the transversal and parallel lines next to different parallel lines. Again, don't love that I have to define these, but I do. We just need to make sure we know which are which. So really the key here is angles in the same, whoops, tried to change my pen and it didn't work out for me. Just did a nice line here. Angles in the same position. That's the key, what we're looking for here. So for instance, angle 2 and angle 6 equal each other. They're in the same position between the first parallel line and the second parallel line. That would be one set. Another set, my picture's kind of going out of sight. I don't want to have to go too far. Angle 1 is equal to angle 5. Because they're in the same position. And then 4 and 8 and 3 and 7. Okay, so we can put that down as well. Angle 4 would equal to angle 8. Angle 3 would equal to angle 7. Okay, leave a little gap if you're taking some notes. I see that some of you are very carefully taking notes. Leave a bit of a gap in case there's one more I need to note here. I think I got them all. And I'm going to scroll up and I'm going to put an example down and we're going to play around with an example. We'll do a pretty easy example, quote unquote, and then we'll jump into some harder ones, see if we can make that leap. Okay, so here's example 1. And I won't make us find every single angle, find the missing angles. And in my diagram, I won't make a million. Okay, let's put our parallel lines this way just for fun. That's our transversal. And I will give you that this is 78 degrees. And then we'll find 3 different angles. So I'll call this guy A. I'll call this guy B, and I'll call this guy C. We'll try to find A, B, and C. Okay, so I'm going to give you a chance before I do it to tell me what the value of A is, what the value of B is, and what the value of C is. So mess around. I can give you a hint. There's not a lot of calculation you have to do here, just a little. And at this point too, if you're really stuck, you could also just give me that individual feedback privately in the chat. And then I would have a little bit of a better flavor of how much more I need to explain. If you're not having any issues, work away and get A, B, and C, and then just type those up for me in the chat bubble. Okay, I'm going to jump back in here. Would anyone like to come on the audio and tell me their thoughts on angle A? No one got the gumption? Anyone want to type it to me? And then I'll grab it. I can just not identify you if I get the right answer. What's A? Oh, someone's going to give me some help here. Yeah, oh, no problem if you're just catching up on the notes. Anyone want to tell us what A is? How big is A? Yes, A is 78. Excellent. Now, let me write down the answer. Thank you very much to the student who gave me the right answer. We also always want to put a little explanation as to why. We don't need to put all the definitions in, but we need to say A is equal to 78 because it is opposite the given 78. Okay, so when you look at the assignment, I'm trying to do some questions that are sort of similar to the assignment and the restriction number 6, I think, on the assignment particularly. So you have to make a little explanation as to why. So they're vertically opposite. Well, sorry, I call them vertically opposite. They're opposite because they're directly across a vertex. Okay, so we've got A. Now the next one we would want to find is B. Let's move this down a little bit. He's a little trickier. So let me go to the crowd again, because I love if you guys can help me out. Anyone want to give a guess for what 78 is? And you know what I could do here is I can page you back up a little bit here. And we do need to put one more. See, I knew I would have missed one. So let's go back up here where I had told you to leave a little gap. There's one other kind of angles that we need to talk about. So let's slip it in here. Interior angles. Not alternate interior angles, but interior angles. They are angles between the parallel lines next to, whoops, say that a little bit different. Angles between the parallel line on the same side of the transversal next to different parallel lines. And these ones, they add to 180. Angles between parallel lines on the same side of the transversal next to different parallel lines. Oh my goodness, no wonder you guys have trouble, right? All these definitions. In our example down here, A and B are interior angles. So let's just leave this example one for just a second and go back up to our example up here where you have your notes. Interior angles would be 3 and 6, these guys. They're on the same side of the transversal next to different parallel lines. So we would say here that angle 3 plus angle 6 equals 180. Or if we go back and sneak a peek, angle 4 and angle 5 at 180. Okay, I better give you a second to write that down. It's quite wordy. I don't know how to make it not wordy. And once you have that down, anyone want to give us a guess as to what the angle B is? Okay, excellent. So the way you find this, thank you very much to those two students that gave me the answer. So the way you find B is you go 180, take away A. Now we all know that A is 78. So 180, take away 78, grab a calculator out to double check that. and you find the answer is 102. And then in terms of answer, or in terms of reasoning, we just say interior angle to A. Great. Now we've got A answered and we've got B answered. Anyone want to jump in with C? No more calculations have to be done. There's very little calculating that has to be done in these questions. Anyone want to give a shot at C? All right, someone's giving her a go. So this, we have to be careful. You can see there's two answers. It's either going to be 78 or it's going to be 102. Those are the only two options. Okay, we have to try to figure out, is it 78 or is it 102? So you're going to you kind of have a 50-50 chance at this point. Again, here's your vertex or your kind of your where the two cross. So B and C are across from each other. Okay, those are called opposite angles, and so they're equal. So whatever B was, C is also the same thing. So C is 102. Why? Because it is opposite angle B. Now, what you'll find in these questions, if I was to say fill in this entire chart, I'm just going to redraw it. These are our parallel lines. This was our transversal line. I told you this was 78. Watch how this fills in. It's kind of cool. So this is 78. We'd found that. Oops, I need more room. Sorry, I'm going to move this parallel line over a little bit more because my writing is a little bit big. Okay, so we had found this to be 78. Then we found this guy to be 102. And if we find this guy to be 102, everything is symmetrical, remember? So the 78 here also goes here. The 78 here also goes here. So this guy becomes 78. This guy becomes 78. And then the 102s come over here. So really, surrounding one of the crosses, the angles across from each other are equal. The angles across from themselves this way are equal. And then you sort of think of cutting the picture in half and moving them over and just sliding them over. And then you just repeat them. So even though I've given you all these, descriptions of all these different things, which is important to know, bottom line, we want you to get the right angle, right? So think of that. So I've got a picture to put up as our last example here. And I have a couple. Maybe just throw two up and see which one we want to do, because I don't want to keep you too long. Where did I put this? On my desktop, I think. Well, let's import this and see which one this was. Okay, this is a pretty tough one. Make it bigger here so you can read it. Okay, well, let's play around with this one a little bit. Maybe we'll see how many angles we can find. Lots of different things going on here. You can see we've got a set of parallel lines, and I'll use my highlighter. These are your parallel lines. Oh, goodness, I was trying to use my highlighter. That didn't work. Here, because you can see the arrows on them. So I'll highlight the parallel lines. All the rest of the things are transversals. So if you wanted to, you could kind of cut this apart and do all the different angles by cutting it apart into 3 separate sections. So we could take, and maybe I'll just do that with a different color. I'm going to circle it in yellow, and let's just take the yellow piece and redraw it over here. So I'll make it look like this, like this. These are our parallel lines again. This is C. They give us the letter N there. Oh, it's not, you know what, I'm going to draw my transverse a little bit more sloped. Like that. This was N, this was 28 degrees. This was F, and this was S. And this is Z, and this is X. Oh, there's a lot of rewriting. So we'll do this piece. Now I'm going to ask you to do some little thing for me. Once you get that drawn, does everyone know how to label an angle with 3 different letters? If you do, can you use the thumbs up? And if you don't, can you use the thumbs down? There's a little emoticon that you can choose. And if you can't find it, you can just type to me yes or no. Just so I have a little bit better thought as to whether we know how to do this or not. And I'm going to go through it. I just wanted to get a little bit of a flavor. Okay, so if I wanted to name this 28 degrees right here, this guy, I could name it by going N to C to X. 28 degrees is between N to C to X. So we could name this, and I don't think this comes up a lot, but it's really good information for any other math that you're doing. We could say angle NCX was given to be 28 degrees. So in case they ever ask you to use 3 letters, it's really good for trig that you would have done last module. You start, you get to the corner guy is always your angle, and then where you're going to is 28. So when we go to fill this in, this is opposite, so that's going to be 28. Someone do the 180, take away 28 so that we can get angle BCN. I don't really have a third one. This angle right here in orange. What's that angle in orange? Someone give it to us. I see we got lots of people getting involved. Fantastic. What's that angle there? Remember, it's on a straight line, so it's going to be supplemental to 28 degrees. What do we think that orange angle is? 152. It exactly is. Good. A whole bunch of you are giving it at the same time. And again, because they are around one angle, 152 on the other side is the opposite. Now remember what I was talking about here? Look at how easy this becomes. I'm trying to make these easier for you. I know I had to do all those definitions at the beginning, but if we kind of cut this apart here and snuck it together, can you see that all those 4 angles would just superimpose? And so they would just drop down and it would go 28, 152, 28, 152. So many times there's really only a couple of answers that you're going to get. Okay. All right, I'm going to wrap it up there.